Okay, we're having a look at the question here that asks us to find the turning point of each quadratic function and use the coefficient of x squared to state whether the turning point is a maximum or a minimum. Okay, so the coefficient of x squared, of course, is the number in front of x squared. When there isn't one, we know it's 1, but more importantly, we know it's negative minus 1x squared, which gives an upside down U shape, which means that the turning point is a maximum, or max for short. Okay, so our function, which can be written either way, minus x squared plus 6x plus 5, nothing has changed, just the order. And the first step is to differentiate, because dy dx is the slope of the tangent. So we will get minus 2x plus 6, and we let that equal to 0, because the slope of the tangent at the maximum or the minimum turning point will always be 0. We'll look at that a little more in the diagram in a second. So minus 2x plus 6 equals 0. We want to find x. Minus 2x equals minus 6. X equals 3. When we have x, we want to find y. So we're going to substitute x back into the original function to find its value. Minus 3 squared. Now it's important to substitute this in correctly in your calculator. If you put that minus inside the bracket, it will not work out. So 3 squared is 9, minus 9, plus 18, plus 5, y equals 14. So now we have x equals 3, y equals 14, and that will give us a coordinate 3, 14, which we know is a maximum turning point. Okay, so let's have a look at the function in the diagram. We won't have this in the question, and we're not being asked to draw it. So the x value is 3. You can see that here. We can trace it up along. The y value is 14, which is here. We can trace it over, which gives us the maximum turning point 3, 14. So we have our upside down U shape in the function, and we also see that m equals 0. That's the slope, so that's dy dx equal to 0 for the tangent at the turning point.